Alright, we're back again for our next lesson. Today we're going to talk about linear equations, which is 7.3. It's really no different than what we already did with functions in 7.2, but now we're going to take our information, we're going to continue to find that function rule, probably create it with a couple of word problems, fill out our table with our x and y, our input and our output, and then this time we're going to actually take our ordered pair and we're going to graph it. So it's a combination of 7.1 ordered pairs in coordinate plane and 7.2 with functions. So let's take a look at the notes. So our learning target is I can generate ordered pairs using function rules. So if you remember in our last problem that we did in 7.2 together in the notes, we added a column and it was an x and y, which was our ordered pairs. So that's what we're going to be doing today. So the difference between a function and a linear function is a linear function is a function that makes a straight line when graphed. So if you look at our problem here, that graph is a straight line, so therefore it's a linear function. Not all graphs are going to be straight. For the most part, we're going to talk about linear functions, so all of them will be straight. So here's our equation. It should look relatively familiar because we talked about things like this when we did functions. Y equals 2x minus 1. You'll remember, or you should remember, that the x is the input, the y is the output, and then this 2x minus 1, that's our function rule. So if we take a look at our graph, you're going to notice that there's 1, 2, 3, 4 different points on there. So if we take a look at this one, let's take a look at this one right here. That one is x equals 0. So if I go to my function rule and I plug in x equals 0, 2 times 0 is 0, minus 1 is negative 1. So that's how I got that point. That point right there is the point 0, negative 1. So I also used the inputs negative 1, and we talked about 0, and then 1 and then 2, and I connected the lines and added arrows to make our graph. So let's take a look at a couple examples. So it's best to always do the function table first and then go ahead and graph. You're going to notice that our equation is y equals 3x plus 2. I already put the 3x plus 2 and wrote it into our table, and that's going to be our function rule. You also notice I've already filled out 2, 1, 0, negative 1, negative 2. When you're asked to create a graph, you should always use 5 points, and those are the 5 points I would always recommend using. Make sure you use 0 because that's the easiest, and then make sure you use 2 positives and 2 negatives, 1 and 2 being the next, because you don't want to use decimals or fractions. You could, but whole numbers are definitely easier. So if you remember, we're then going to take our inputs and we're going to plug them into our equation through substitution. So I'm going to rewrite my problems here. So 3 times 0 plus 2. I'm going to keep going until I filled out this column. Alright, now we can go ahead and we can use our order of operations to solve for our output, which is going to be our y. Remember, you need to follow order of operations, so I'm going to always do this multiplying right here. I need to do this multiplying first on all of these problems before I add my 2, otherwise my answers aren't going to be the same. So 3 times negative 2 is negative 6, negative 6 plus 2 is negative 4. 3 times negative 1 is negative 3, plus 2 is negative 1. 3 times 0 is 0, plus 2 is 2. 3 times 1 is 3, plus 2 is 5. 3 times 2 is 6, plus 2 is 8. You will notice that there is a pattern. On each one of these, there is a pattern. So now I can take my x and my y values, and I can create my ordered pairs. And I'm just pulling these right from the table. Remember, if you have any questions, school has messaged me, and we can set up a meeting, and we can walk you through things. Alright, now I've got my 5 ordered pairs. I'm going to go down to my graph, and I'm just going to start graphing them. I'm going to start with negative 2, negative 4. So, negative 2, negative 4. Put that right there. Next one is negative 1, negative 1. And then 0, 2. 1, 5. And 2, 8. Okay, last I'm going to draw my line as best as I can. And I'm going to draw my arrows. I know that looks a little off, but since we got our points there, we know what we're doing here. Alright, Let's take a look at our next one. Our next equation is y equals 2x minus 5. Remember, the x is going to be our input, the y is our output, and the 2x minus 5 is our function rule. So I already dropped that down into our table. Now I'm going to use substitution, and I'm going to plug in my inputs. So I'm going to use -2, -1. Notice how the function rule stays the same. The only thing that's changing is the x values. 0, 1, and then my last one then will be 2. Make sure you're following order of operations. So again, this time I need to do all of this multiplying first before I subtract 5. 2 times -2 is -4. -4 minus 5 is -9. 2 times -1 is -2 minus 5 is -7. 2 times 0 is 0 minus 5 is -5. 2 times 1 is 2 minus 5 is -3. And 2 times 2 is 4 minus 5 is -1. Notice again there is a pattern here, and I know that I haven't talked about the pattern, and that's for a reason. We're going to talk about that in the next couple lessons. Okay? So I can take my x and my y values, and I can change them into an ordered pair by just copying them right off of the table. So -2, -9, -1, -7, 0, -5, 1, -3, and 2, -1. Okay, now I'm going to take my ordered pairs, I'm going to put them into my graph. So my first one is -2, -9. So 2 to the left, down 9. Next one was -1, was it -7? Yep. 0, -5, 1, -3, and 2, -1. Now you'll notice that this graph looks a lot different. It's still a straight line, but notice where our points are. So I'm going to go ahead, I'm going to connect them as best as I can. And then don't forget to draw arrows to understand that I could have picked other points and that line does keep going. Okay, so there's our linear function. That's pretty much it. The only difference between yesterday and today is now you're taking your ordered pairs and you're making a graph. Let's take a look at a word problem. Write a linear equation for each situation, then graph the equation. Number 1. Lauren is picking zucchini from her garden. She currently has picked 20 zucchini and can pick 5 each minute. Let x be the number of minutes and y be the number of zucchini. So I went ahead and I marked our text already. We need to make sure that we're writing a linear equation, and then I have my table there to fill out, and then I'm going to go ahead and I'm going to graph it. With word problems come a couple other things when we're graphing. We'll talk about that here in just a minute. So the first thing I want to do is find my equation or my function rule, and I did highlight that in green. It says that Lauren has picked 20 zucchini already, so that's what she currently has, and then she picks 5 each minute, so it's going to be added to the 20 that she already has. So it's 5 for every minute. So after 1 minute she's got 5, after 2 she's got 10, after 3 she's got 15. So it's a multiplication problem. So it's going to be 5 times the number of minutes, and then she already had 20. So I'm going to have to take that number that I generate there, and I'm going to add 20 to it. Now I can decide what I want to use for my x values. This problem does not tell us what to use for x values, but we need to talk about that a little bit, because in our equations we use 2, 1, 0, -1, and -2. This time x is representing the number of minutes. So it doesn't make sense to use any negative numbers. So I still like to start with 0. Because that's an easy one. And we're talking about minutes here, so I mean, maybe is she picking for 1 minute at a time? Is she going to pick for 5 minutes at a time? It's totally up to you. I think for our problem here, I think I'm just going to do, I'm going to do 1, 2, you know what, let's mix it up a little bit. Let's go 2, 4, 6, and 8. And you can really pick whatever ones you want, okay? I'm going to go ahead, I'm going to substitute them in. So I got 5 times 0 plus 20. 5 times 2 plus 20. Notice how the only thing that's changing is our x value. 5 times 4 plus 20. 5 times 6 plus 20. And then 5 times 8 plus 20. Alright. So I'm going to go ahead and I'm going to use order of operations to make sure that I'm getting the correct output. Don't forget you need to do this multiplying here first. That's not always going to be the case. We just need to make sure we're following order of operations. So she doesn't pick anything today, right? She picks for 0 minutes. She still has that initial 20 that she started with. She picks for 2 minutes. 5 times 2 is 10 plus 20 is 30. 4 minutes. 5 times 4 is 20 plus 20 is 40. 5 times 6 is 30 plus 20 is 50. And then 5 times 8 is 40 plus 20 is 60 here. I'm going to go ahead and we can take our x values and our y values and we can create these ordered pairs. So we have 0, 20, 2, 30, 3, 40. Did I screw that up? Is it 440? 6 and 50 and 8 and 60. Okay. Now we can go ahead into our graph. Now you'll notice that there's only one quadrant in this one. That's because there's no negative numbers. So the first thing I'm going to want to do is I'm going to want to label my axis. In our problem it tells us that x is the number of minutes. And it says that the y is the number of zucchini. Did I spell it right? Nope, 2 C's. Okay. Now I'm going to go ahead and graph, but I need to make sure that I'm spacing this out as best as I possibly can with the numbers that I have. We don't want this tiny graph that only goes like that. Okay, we want to use up as much of the space as we possibly can. So I think we're going to count by tens here. So I think this is going to be 10. So 10, 20, 30, 40, 50. 10, 20, 30, 40, and then 100. And then down here, I think we could probably get away with still counting by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that should look all right. Okay. All right, so if she starts with 0, she ends up with 20 zucchinis. She doesn't pick it all, she's got 20. Then she goes for 2 minutes, she has 30. 4 minutes, 40. 6 minutes, 50. And 8 minutes, 60. Now go ahead and draw your line as best fit. You can extend it, but this time you're going to only extend in one direction because I can't have a negative number. That way we can now use our graph then to figure out if she graphed for, if she picked for 10 minutes or 12 or even 100, you'd be able to figure out relatively quickly how many zucchini she had. Alright, that's enough for our lesson for today. Hopefully that helps. It's really a combination of 7.1 and 7.2. Don't forget to do those IXLs. Both of those will be graded, and the blue sheet is there for you for extra help. Make sure to message me on Schoology if you need anything. Peace, guys. Bye.